Welcome everybody to the Bernd Sheehan event on big data. My name is John Sheehan and I'm your host for the evening. You're joining us at quite an exciting time for Bernd Sheehan because we're going to be 10 years old next week, so happy birthday to us. The rest of the Bernd Sheehan team are surrounding you. They're all in the blue ones of these and they're probably dressed pretty much like you guys because we don't really go for the sharp suits and the ties these days. So say hello if they're anywhere near you. We've got two great guys in Andy and Dave who have volunteered to give theirs and their company's experiences around big data from two very different worlds. AndyDone is the data platform lead for King. Dave Ellerman, who heads up the tech consulting at ThoughtWorks, specializing in machine learning, big data and scaling solutions via the cloud. ThoughtWorks, obviously a global leader, global tech company, over 2,500 people in 29 different countries, and probably counting, Dave, isn't it? Big data is getting a lot of press at the moment, and I think it's safe to say that most of us in the room have probably seen or heard the joke about big data being like teenage sex. Everyone is talking about it, but nobody really knows what to do with it. From purely a recruitment point of view, in terms of actually a skill set, what a lot of clients and a lot of companies are looking for, I haven't seen something quite as explosive a skill set as the word agile came about in London in 2001. And it's surprising to us, like agile, it's incredible how many people have suddenly got big data on their CVs when actually it's very hard to find these people. We're going to have a slightly different format from previous events. Unlike a break in between, we're going to have one presentation after the other, and we're going to have a Q&A session after each presentation. However, what I would say is, if you don't get time to ask your question, grab these guys afterwards because you will not find two more engaging guys. So after all that, I'm handing over to Andy. Andy, over to you, mate.
Good evening, everybody. Thanks, John, for that warm welcome, and thanks for hyping me in the same way as people are hyping big data. I'm AndyDone, it's true, and I am the data platform lead at King. So I want to start just by looking at this big data concept. What is that? I think we all have an instinctive idea what it is, but let's unpack that phrase and try and get some more detail. What is big data? So Gartner, I believe, come up with this 3 V's concept to describe what is the sort of amorphous blob that we all know as big data. They describe big data as having 3 characteristics: volume, velocity, and variety. So that's good because that's an acknowledgement that this big data word has some dimensions, it has some qualities, and it's more than just a slogan. But this immediately gets you into problems. What if you've got a project with massive volume, a huge variety of data, but it actually arrives quite slowly, maybe once a day, in a bunch of hard disks in the back of a truck? Does that mean you don't have a big data problem? Who knows? Some people are even talking about the 4 V's. They've added veracity to this concoction, which I had to look up. It's not veracity. Veracity means kind of truth or accuracy in data, and I kind of hope that there's an element of that in most data projects, but maybe I'm just being idealistic. So we stand here, we make a declaration, our data is big. So I realized now, thinking about it, that it was my junior school English teacher that actually equipped me with the tools to stand in front of you today and explain this a little bit. So we were like 7 years old or something. I just come back from summer holidays, and our class teacher gave us a project to do. I said, write a short piece about your summer holidays. Great, that seems pretty easy. Here's the catch. You can't use the word big. So this was kind of a problem for bunch of kids whose big was their primary adjective. We didn't have many other tools in our belt. We went, took a big drive to the beach. The waves were big. I ate a big ice cream. I rode on a donkey. It was big. I drove home and had a big sleep. That's not very useful. So if you say the same thing about your data, say our data is big, well, it's not just big. It is lots of things. And I think it's much more helpful to acknowledge that and dig into your data and start asking those questions. So what qualities does your data have? What characteristics does it have? Because in acknowledging that, you acknowledge that there may be more than one way to solve your big data problem, and there may be more than one tool, with which to do so. So what's so great about a dimensional model? Why do we bother to build that? Well, it transforms your data into a form that's much easier for end users to take advantage of and use. It's much more friendlier. It gives you a flexible framework, a scaffolding where to hang elements of your data and make them easily understandable and discoverable. The data warehousing industry, dimensional modeling, that's 20, 30-year-old industry. So there's a huge reservoir, a huge bag of techniques and tricks that have been worked on throughout those 20, 30 years. So if you've got a problem, it's very likely that someone will have already solved that once upon a time. It also provides a nice way of structuring your thinking, structuring the way you think about your business and the way you conceptualize the data within it. So let's look at both those things now, so our raw data and our dimensional model. So they're both actually quite well structured. As I said, our source data is kind of tab-separated column data, and our dimensional model itself is well structured. It's tables, it would fit well in a database. And that got us thinking, because we're appreciating the strengths of Hadoop, the scalability, the resiliency. You can lose machines, you can lose disks. We lost a whole rack once, and it was fine. It's a very flexible system, and it gives you very low cost but accessible storage. The alternative would be put that huge amount of data on tapes or a SAN somewhere, and maybe you never see it again. But with Hadoop, you have an efficient processing framework that you can use to get at that data. And it's also very good at unstructured and semi-structured data types, so things like images, PDFs, stuff that isn't kind of columns of numbers and that kind of stuff. But there's some weaknesses too. So working over that structured data, the performance in Hadoop actually isn't that good. It's often not that easy to use, and it requires quite a lot of maintenance, care, and feeding, so you need a reasonably skilled people to make that thing work for you. But what's really lacking is fast data exploration. If you're a data scientist or a business user, you want to kind of pop open a table, have a little look in there, sort of count some columns, see the distinct values in something. Just kind of fast slice and dice stuff to get a feel for your data, and that is quite difficult to do in Hadoop. Joins, which is bringing two tables together, that is also quite challenging for the processing framework MapReduce that runs on top of Hadoop. It's not a very natural operation to do there, and unfortunately it's something you do quite a lot of if you've built your data into a dimensional model. So let's just look at some numbers here and compare these two worlds, the Hadoop and the database world. So if you look at performance by price, so how much performance do you get if you're going to spend $1 or more? So if you compare something like Exasolution to Hive for working with this structured data, what you find is that the Exasolution was, I don't know what that is, about 20 odd times better value for money in terms of performance price than trying to do that workload in Hadoop. Just to put that sort of in pictures for you, we found that about 4 Exasolution nodes to get the same performance in Hadoop for that structured data, we would have needed to deploy over 400 Hadoop nodes. That sounds great, but there's another flip side to that. Let's look at the price per terabyte of usable storage. I say usable storage because in Hadoop world and in scalable databases, there's often redundancy, multiple copies of the data, so I'm talking about actual what you can really store here. If you try and store that on database grade servers, so reasonably high-end machines with nice fast disks, that's going to cost you for us, about 7 to 8 times more than trying to store that in Hadoop grade servers, which are cheaper, commodity machines, you can use bigger, slower disks. So what's the point of all this? Well, the point is that there's two very different use cases there. What we're trying to do is get the best of both worlds. We want that scalable, resilient, flexible, low-cost storage system that Hadoop gives us, but we also want really good performance over our structured data. We want it to be easy to use, low maintenance, to explore our data quickly and do things like joins efficiently. And that's what the database gives us. So behind big data lies many diverse requirements. So rather than labeling everything with this phrase big data, I think it's helpful to start unpicking that, look in detail at the qualities your data has, and look at the unique problems your data might have, and solve them in specific ways. So despite what all the vendors might want to tell you, there is currently not one good tool for that job. Maybe there will be one in 3 or 5 years, I don't know. But right now, I believe that hybrid architectures give you the best of more worlds, and whether that hybrid architecture is Hadoop plus a database, plus a real-time system, or some other combination, I think that is currently the only way we see to solve all these problems simultaneously. So thank you very much for listening. Appreciate your attention. Yeah, I'll be very happy to take any questions now.
What I would like to ask is that regarding your quest to go onto the real-time path, did you consider looking into the Amazon Velocity implementation, or even in-house or something like that? Because I think this is something along those lines what you are trying to implement right now. More generally, kind of loads of things what you are talking about, the things that like we're kind of targeted in the cloud space anyway, one provider or the other. So I just wonder if you looked into this solution, or at least looked at your problem from this angle.
So the question was if we're looking at things like Amazon Velocity, but as an in-house solution. Yeah, sure. So that's a good point. So just for clarification, so King, we host all our data ourselves. We run our own data centers, so we don't have any cloud solution. So we have teams looking at the real-time problem. Right now, we structure our solution around the Kafka project, Apache Kafka. So that's our real-time event queue. We're currently doing R&D projects to look at the various ways that you could take data off a Kafka stream and process it in real time, and how all these pieces fit together. So as I was saying, the huge value you've created on the right of that picture with your dimensional model, it'd be fantastic to somehow be able to expose that to a real-time system in a meaningful way, so that it has to do less work and can take advantage of all that, all that pre-processing that's happened.
I only ask because these big cloud providers usually provide on-the-premise solutions, or some of them like provide on-the-solution implementation for their solutions. So just like I wonder if you can, probably it's depending on the scale and how much it costs. So it's, I don't know.
Yeah, exactly. I think real-time, more so than almost anywhere else in that picture, is the area where you really, really need to focus on your requirements. Because if you try and just make everything real-time, then it becomes a hugely expensive and probably futile exercise. So I think real-time is very much about looking at specific use cases and solving them in specialist ways. I'm sure in coming years there'll be a lot of innovation in that space, and maybe we will have a kind of solution that fits neatly into that gap. Right now there's a whole bunch of contenders, and yeah, we're actively looking at several.
Hi, over here. I was interested in what you said about the data model evolving.
Yeah.
particularly because I picked up on the fact that you are generating your own data right now, presumably because I assume you're not using any tracking solution like GA or anything like that for any of your...
No, we are the tracking solution.
So you generate your own data.
Yeah.
So how are you currently dealing with that challenge of the evolving sort of data model or the schema in your solution?
Yeah, so some of the, so it's a good point to mention that you'd think we have our own games, we run our own data platform, what kind of mismatch could there be there? So there was always some kind of tension between the systems producing the data and the most convenient way to produce the data and the most convenient way for us to consume it. So that's always something of a compromise. We try and make sure that it's designed well for both of us, but often we can't achieve that. So we've got specific problems around, for example, identifiers, which are really hard in mobile. So iOS 7, for example, changed the way that Apple devices identify themselves. So for us, when we're trying to understand player behavior, and when IDs in the real world are changing, keeping the linkage between IDs and understanding that and presenting that in a way that a business user or a data scientist doesn't have to worry about it is kind of interesting. And we try to solve that problem in our dimensional model using fairly traditional dimensional modeling techniques with durable keys and all this kind of stuff.
Slowly changing dimensions.
Right, exactly. So our problem is that our dimensions are so large. We have billions of rows in our dimension tables and hundreds of billions in our fact tables. So doing slowly changing anything is kind of tricky. So we have to make a really strong case for that kind of explosion that would happen as a result of that. But yeah, these are really interesting problems. We lean heavily on the kind of techniques from the traditional dimensional modeling world. We're learning about a lot of that too. So it's challenging. Yeah.
Thank you.
Thanks very much.
Probably take one more. Anybody got over there? Perfect.
Yes, hi. Andy, a lot of the data you're talking about at the moment is structured data.
For us, yes.
Yeah, on the roadmap for King, do you foresee products or services or games that you will need to capture unstructured data and actually do analysis in semi-real time in that way?
Yeah, so the first question, I guess, is do we see unstructured data coming to the business that we want to make use of? And then I guess you're poking me with another real-time question about doing that whole piece in real time as well. So we don't currently have a strong use case for processing that data into our data warehouse. If we're doing things like sentiment analysis, then that's generally handled by some kind of third-party system. We look at aggregated results back. So it is a very interesting problem space, which we don't yet have a compelling use case for in-house. I would love to be at the meeting where we decide that we not only need to do that, but do it in real time, because I think that would be a very terrifying but exciting discussion. Yes, nothing really concrete on that in-house yet. Thanks a lot.
Thanks, Andy. Thanks very much.